All right, so we got this new paper hot off the press from Google DeepMind, SigLIP 2, Multilingual Vision Language Encoders with improved semantic understanding, localization, and dense features.
Quite a title.
Yeah, it's a mouthful, but I think the paper itself is worth really digging into.
Oh, absolutely. And what we're looking at here is really a whole family of multilingual vision language encoders that are really kind of pushing the boundaries of what AI can actually do with images and text.
Yeah, you're telling me, and it's not just hype either. I mean, this paper is absolutely packed with details about how SigLIP 2 is outperforming, its predecessor, SigLIP, and a bunch of other open-weight models in zero-shot classification and retrieval, and even dense prediction tasks.
Yeah, and one of the things that I really liked about this paper was that they really tackled cultural diversity and fairness head-on, which is something that we really need to be considering as we develop these very powerful models.
For sure. For sure. Well, let's break it down for our viewers, who are maybe just kind of skimming through their YouTube feed right now. Let's give them the TLDR.
Okay, so the TLDR on this is that SigLIP 2 builds upon the original SigLIP model, but combines it with several prior techniques that have been shown to be really effective in previous research.
Like what?
So we're talking about things like captioning-based pre-training and self-supervised losses, and then also really clever online data curation strategy.
And all of this leads to some pretty impressive results, right?
Yeah, so we're seeing state-of-the-art results in zero-shot classification, image text retrieval, and even feature extraction for those working with vision language models, VLMs.
So it's not just a one-trick pony, it's actually a versatile tool.
Yeah, definitely versatile. And I think one of the other things that's really impressive about this paper is this new training recipe that they've come up with, which significantly improves performance in localization and dense prediction tasks. So things like segmentation, depth estimation, really critical tasks.
We'll have to dig into that.
Yeah, definitely. And then on top of all of that, it's multilingual. So they train this model on a massive data set of 109 languages, which is just a huge step towards building more inclusive and accessible AI systems.
Wow. So we're talking about a model that can understand and connect images and text across a whole bunch of different cultures and linguistic nuances.
Exactly. And then to top it off, they've also taken steps to make the model fair by using a diverse training data set and incorporating debiasing techniques.
Okay. So for those of you keeping score at home, SigLIP 2 is available in 4 different sizes: VITB, L, so 400 meters, and G.
Yeah, so you can pick the one that suits your computational needs and performance goals.
All right, now that we've kind of gotten the highlights out of the way, let's dive a little deeper into what makes SigLIP 2 so special, and I think a good place to start would be the training process.
Yeah, they talk about this idea of blending the best bits from previous research, and I think that's a really apt way to describe it.
Yeah, it's like they took all the ingredients for a killer AI model and threw them in a blender.
Exactly. And so they're combining things like this captioning-based pre-training, where they're training the model to generate descriptions for images, and then they've got these self-distillation techniques where the model is actually learning from its own predictions, and then they've got mask prediction where the model has to fill in missing information in images or text.
So it's kind of like giving the model a multifaceted education, exposing it to all these different learning strategies so that it can boost its overall understanding.
Yeah, exactly. And they're also being very strategic about how they're combining these different approaches.
Oh, yeah.
So, for example, they're using this technique called momentum contrastive, learning to improve the model's ability to distinguish between similar images, which is really critical for a lot of tasks like image retrieval.
Now, let's talk about the multilingual aspect of this. I mean, 109 languages is just mind-blowing.
It's pretty remarkable, and what they've done is they've curated this massive data set of image text pairs from all over the world. And what this allows the model to do is learn these cross-lingual representations.
Hold on, back up a second. What exactly does cross-lingual representations mean?
So essentially what it means is that the model can understand the relationships between images and text, even if they're in different languages.
So like if you show it a picture of a cat and the word gato,
Yeah.
it'll know that those two things are referring to the same concept, even though they're in different languages.
Exactly. And so it's not just learning separate vocabularies for each language, it's actually learning a more universal understanding of visual concepts. And this is really powerful because it allows us to start to build AI systems that are more inclusive and accessible to people from all over the world.
That's pretty awesome. Now, let's move on to another area where SigLIP 2 really shines these dense prediction tasks. What exactly are those, and what makes this model so good at them?
Okay, so dense prediction tasks are all about understanding images at a pixel level.
So it's not just recognizing that there's a cat in the image. It's like understanding the cat's shape, its position in space, maybe even the texture of its fur.
Exactly. And what makes SigLIP 2 so good at these tasks is that they've incorporated these self-supervised losses into the training process.
Okay, but how do those actually work?
So imagine you have a puzzle where some of the pieces are missing.
Yeah.
You can still probably get a pretty good idea of what the complete picture looks like.
Yeah, you can kind of fill in the gaps based on the surrounding pieces.
Exactly. And that's kind of what these self-supervised losses are doing. They're presenting the model with an incomplete image, and the model has to predict those missing parts. And by doing this over and over again, the model learns to extract this richer, more localized information from the images.
So it's like training the model to be kind of like a visual detective. Piecing together clues from the surrounding context to understand the whole picture.
Exactly. And this is really important for a lot of real-world applications like self-driving cars, where the AI needs to understand the three-dimensional structure of its environment, or medical imaging, where doctors might be looking for subtle abnormalities in a scan.
Okay, so speaking of real-world applications, the paper mentions that SigLIP 2 is also a great team player when it comes to VLMs, these vision language models. What does that mean exactly?
Okay, so what it means is that you can actually use SigLIP 2 as a building block for other more complex AI systems that combine vision and language. And they specifically tested it as the visual encoder for a VLM called Palagemma 2.
Wait, before you go on, I think it would be helpful to just kind of define what a visual encoder is for those who might not be familiar with that term.
Sure. So basically, a VLM needs to be able to understand both images and text.
Right.
So it needs a way to convert those images into a format that the language part of the model can understand. And that's where the visual encoder comes in. It takes an image and extracts a bunch of features from it, basically a set of numbers that represent what's important in that image.
So it's kind of like translating the image into a language that the VLM can speak.
Exactly. And what they found was that using SigLIP 2 as this visual encoder actually significantly boosted Palagemma 2's performance across a variety of downstream tasks.
Okay, but for our viewers who aren't spending all day building VLMs, why should they care about SigLIP 2's performance as a visual encoder?
Well, I think it means that it has the potential to be a really powerful tool for building more sophisticated AI systems that can do things like...
Hold that thought. We're going to have to pause here for now, and we'll pick up where we left off in part 2 of this deep dive. So see you there.
So we were talking about SigLIP 2 as this visual encoder that gives VLMs like this big power-up.
Right. You're about to give us some like concrete real-world examples of what these supercharged VLMs could do.
Yeah, so imagine you're, scrolling through your social media feed and you come across this video that's got a bunch of different things happening at once. A VLM powered by SigLIP 2 could not only identify all of those things, but it could actually understand the relationships between them, the actions that are taking place, and even generate like a detailed summary of what's happening in natural language.
So it's not just like labeling objects, it's understanding like the narrative, the story that's unfolding in the video.
Exactly. Or think about a robot that needs to navigate like a really cluttered environment. A VLM with SigLIP 2, as its eyes could understand an instruction, like go to the table and pick up the blue mug next to the vase. It could differentiate objects. It could understand spatial relationships and really execute these tasks with greater accuracy.
It's like we're talking about robots that can actually understand our commands, like in a very human-like way.
Yeah, and that's just scratching the surface. I mean, the potential applications here are vast.
Okay, so let's come back down to earth for a second and talk about some of the specific capabilities that are highlighted in this paper. You mentioned localization prowess earlier. What exactly does that mean, and why is it such a big deal?
So think about it this way. Imagine you're trying to teach a robot to fetch a specific object from a room.
Okay.
You could say, get me the book. But what if there are multiple books in the room? You need a way to be more precise with your instructions.
So you need a way to like pinpoint a particular object within a complex scene, even if there are other similar objects around.
Exactly, and that's what localization is all about, and that's something that SigLIP 2 is really good at.
How do they test that?
They use these things called referring expression comprehension benchmarks. Basically what they do is they show the model an image and give it a text description that refers to a specific object within that image, and the model has to identify the correct object based on that description.
So it's like playing I Spy with the AI.
Exactly. And what they found was that SigLIP 2 outperformed previous models on these benchmarks by a significant margin. It really has a knack for understanding those subtle linguistic cues that help pinpoint a target object.
So that's localization. What about open vocabulary prowess? We touched on this earlier, but I think it's worth revisiting because it's such a fundamental shift in how we think about AI models.
It really is a game changer. So traditional image recognition models, they're trained on a fixed set of categories.
Right.
So if you show them an image of something they've never seen before, they're going to have a really tough time classifying it.
It's like trying to fit a square peg into a round hole.
Yeah.
The model's limited by what it's seen before.
Right, but open vocabulary models like SigLIP 2 are different. They're not limited by that predefined set of categories.
Yeah.
They can learn new concepts on the fly based on the context.
So it's like having a model that can constantly expand its vocabulary like a human child.
Yeah, exactly. And they tested this by showing SigLIP 2 images of objects they had never seen before and asking it to segment those objects.
Okay.
And it crushed. It was able to accurately segment these novel objects even though it had never been explicitly trained on them.
Wow. That opens up a whole world of possibilities, doesn't it?
It really does. It means we can start building models that can learn and evolve continuously.
Okay, before we move on, I want to circle back to something you mentioned earlier, NAFLEX. This variant of SigLIP 2 seems particularly relevant for like real-world applications where image size and aspect ratio can vary widely.
Yeah, you're right. So NAFLEX is this really clever innovation that addresses this common challenge in image processing. Most models, they're trained on images that have been resized to a standard square shape, but in reality, images come in all different shapes and sizes.
Right. Think about documents, photographs, medical scans. They're rarely perfectly square.
Exactly. And this can really throw off a model's performance, especially for tasks like document understanding, where the aspect ratio is really crucial for understanding the context.
So how does NAFLEX solve this?
So NAFLEX is designed to preserve the image's native aspect ratio during processing so it doesn't get distorted. And it also supports multiple resolutions, which means you can feed it these high-resolution images without having to downsample them.
So it's like having a model that can adapt to the shape and size of the image rather than the other way around.
Exactly. And they tested this on a bunch of different benchmarks, and it consistently outperformed models that use these standard resizing techniques.
Okay, so let's talk about model sizes.
Yeah.
This is something that's always a consideration when we're talking about deploying AI in the real world.
Yeah, for sure. And the DeepMind team has been really thoughtful about this. They've actually released SigLIP 2 in 4 different sizes, ranging from the relatively lightweight VITB all the way up to this massive G model.
Okay, but for our viewers who might not be familiar with model parameters, can you just give us a quick explanation of what those are and why they matter?
Sure. So think of parameters as the knobs and dials that control how a model learns and makes predictions. The more parameters a model has, the more complex patterns it can learn, but the more computationally expensive it becomes to actually train and run.
So it's this classic trade-off between performance and efficiency.
Exactly. And that's why it's so great that they've released these different sizes so you can pick the one that really makes the most sense for your use case.
Now let's talk about another really important aspect that's highlighted in this paper: cultural diversity and fairness.
It's something that's often overlooked in AI development, but it's really crucial for ensuring that these technologies are beneficial for everyone.
But how do you actually bake fairness into an AI model?
So it's a complex issue, and it requires a multi-pronged approach. They started by using this massively diverse training data set.
Okay.
With images and text from all over the world, this helps to ensure that the model doesn't develop biases towards any particular language or culture. And then they also incorporated these debiasing techniques into the training process.
Can you give us an example of what a debiasing technique might look like?
Yeah, so one really common issue that we see in AI systems is that they tend to associate certain objects or activities with specific genders.
Right.
For example, a model might learn to associate cooking with women and construction with men.
So it's picking up on these stereotypical representations that we see all the time.
Exactly. And to mitigate this, they use these techniques that really encourage the model to focus on the task at hand.
So like identifying the object in an image.
Yeah, rather than relying on these stereotypical associations.
Okay, now let's shift gears a bit and talk about this other really interesting technical aspect highlighted in the paper distillation via active data curation.
Yeah, so they're essentially using a larger, more powerful teacher model to guide the training of a smaller student model.
It's like an apprenticeship.
Exactly. And the way they do this is through this method called ACD, which stands for Active Data Curation with Implicit Distillation.
So break it down for us. How does ACD actually work?
So imagine you're a teacher trying to prepare your student for a really big exam.
Right.
You wouldn't just throw the entire textbook at them.
You want to focus on like the most important concepts.
Exactly, and that's what ACD does. It carefully selects the most learnable examples from the training data based on how well both the teacher and the student model are able to understand them.
So it's identifying like the concepts that the student is struggling with and focusing on those areas to help them catch up.
Exactly, and this allows that smaller model to learn more efficiently and ultimately maximize its performance.
It's brilliant. I mean, in a world where we're increasingly deploying AI on all of these resource-constrained devices like our phones and edge devices, this ability to train smaller, more efficient models without sacrificing accuracy is a game changer.
Absolutely.
Okay, so we've covered a lot of ground here, from SigLIP 2's unique training process and impressive performance to its ability to handle multiple languages, its prowess in localization and open vocabulary tasks, and even its commitment to cultural diversity and fairness.
And NAFLEX, of course.
Right, NAFLEX. So in part 3, I think it's time that we step back and look at the bigger picture. What are the implications of this research for the future of AI? What kind of world can we imagine building with these tools at our disposal? Join us next time as we explore the exciting possibilities unlocked by SigLIP 2. All right, so welcome back to the deep dive.
Yeah.
We spent the last 2 segments really unpacking the impressive capabilities of SigLIP 2, this multilingual vision language powerhouse from Google DeepMind.
Yeah, it's been quite a ride, and it's clear that they're really pushing the boundaries in AI research with this one.
Totally. But now I want to talk about the future. Like, what does all of this mean? What kind of impact could SigLIP 2 have on the world? What are the applications that get you like really excited?
I think for me, it's really the potential to bridge this gap between humans and machines in a way that we haven't really seen before,
Yeah.
Well, think about it. SigLIP 2 can understand images and text across multiple languages. It can pinpoint details in really complex scenes, and it can even learn new concepts on the fly.
So we're talking about AI systems that can interact with the visual world in a much more human-like way.
Exactly, and that opens up so many possibilities.
Like what? Give me an example.
Okay, so let's start with something as simple as online search.
Okay.
Imagine being able to search for images using natural language descriptions, like a photo of a sunset over a mountain range with the lake in the foreground. SigLIP 2 could understand the nuances of that query and retrieve images that perfectly match your description.
Wow, that would be amazing. No more scrolling through endless pages of search results just to find one good image.
Yeah, and that's just one example. Think about e-commerce. Imagine being able to shop for clothes online by describing what you're looking for, like a red dress with a floral print knee length, perfect for a summer wedding. SigLIP 2 could understand that and help you find exactly what you need.
It would completely change the way we shop online.
And it goes beyond shopping. Think about content creation. You could use SigLIP 2 to generate realistic images or videos from text prompts.
So you could like create images for your website or custom graphics for social media, or even produce like a short animated film.
Exactly. The possibilities are really endless. And let's not forget accessibility. SigLIP 2 could be used to develop assistive technologies for people with disabilities.
Like what?
Well, imagine a smartphone app that could describe the world to a visually impaired person using SigLIP 2's ability to generate accurate captions for images.
That would be life-changing for so many people.
And think about education. SigLIP 2 could be used to create personalized learning experiences that are tailored to individual students' needs.
So like an AI tutor that can adapt to each student's learning style.
Exactly.
This is all super exciting, but we also need to acknowledge the potential risks and challenges.
Right.
Right, like any powerful technology, AI can be misused or have unintended consequences.
Oh, absolutely. We need to be mindful of those downsides
Yeah.
and develop these systems responsibly. We need to be aware of potential biases in the training data and make sure that these systems are used in a way that benefits society as a whole.
So it's really about having those tough conversations about ethics and privacy and the impact of AI on society. We can't just blindly embrace these new technologies without thinking about the potential risks.
I completely agree. It's so important to involve diverse perspectives and prioritize transparency and accountability.
It's like we're at the edge of a new frontier.
Yeah.
AI has the potential to revolutionize so many aspects of our lives,
Yeah.
but we need to approach it with wisdom and a commitment to human values.
It's a really exciting time to be working in this field, but it's also a time for caution and reflection.
Well said. This has been an incredible deep dive into SigLIP 2 and the future of AI. Thanks for joining us, and we'll see you next time on The Deep Dive.